All right, we're back for another podcast for fiber optic, and we're going to start talking about how fiber optic is made. This usually is one of those questions that, as we start talking fiber, people are like, well, how in the world do they make? So I always take a few minutes and talk about how they actually make this. And this is kind of a follow-up to our discussion earlier on Corning Glass and Keckmauer and Schultz figuring out how to make fiber that had that low signal loss, that would be able to send data across a fiber optic cable. And what they figured out was the fiber optic cable needed to have two parts, the core and the cladding, and they also figured out how to make that where they used a process of making the glass from a gas. If you remember what we said earlier, you know, a solid can hold lots of impurities, a liquid can hold some impurities, but a gas can hold very little impurities. With a gas, you're talking about ions, charged particles is about the only impurities that a gas can hold. So the Keckmauer and Schultz at Corning Glass figured out, hey, let's make our glass from a gas. That way we can control the impurities in there and make our glass super clear. So the process they use is called inside vapor deposition. They take a tube of glass. This will eventually become the cladding. They take a tube of glass, and actually they make the tube from a gas as well. This process doesn't talk about that, but they actually make the tube of glass from a gas. That way they can control the impurities in there and the construction of it and the indices of refraction of that cladding. That tube of glass will become the cladding of the fiber. They take that, and here's the chemical compound, silicon chloride. We think of it as, you know, sand, if you will. They take those tubes and fuse them together so they have a tube long enough to make the fiber that they need to be made long enough. They actually heat up the end. They use a hydrogen-oxygen flame because the byproduct of a hydrogen-oxygen flame is water. You don't have the carbon impurities of like an oxyacetylene flame. So they heat it up. They fuse tubes together to make a glass tube long enough to make the length of fiber they need to. They then heat it up again, and they actually pump into that tube a mixture of gas. Silicon chloride and oxygen are pumped into the fiber. Well, this, as they heat it, will now start to put a layer of soot on the inside of the glass tube. This is them pumping the gas into the tube. Well, if you think about if you cook over a fire, the bottom of your pan is going to have a layer of black soot on. That's the carbon from, you know, burning and the flame and all that jazz. They're doing the same principle here. They have this glass tube and they're pumping a gas in, and as they heat it, it puts a soot on the inside of the glass tube. Well, that soot is eventually going to become the core of the fiber. So this gas mixture allows them to control exactly the composition of that soot, and therefore the composition of the core of the fiber. So they continue to heat that until it gets to be like a glass-like substance. Again, they're going to continue heating it. And then they continue to heat it some more until the tube itself starts to collapse. And actually, through a process, they very slowly kind of squeeze the tube down until it gets smaller. And then they keep heating it until it collapses down on itself. Here's them heating it some more. Until it forms what's called a preform. This glass tube has collapsed down, and you can kind of see the core in there. The tube is going to be the cladding. The soot on the inside that was deposited and heated up is going to become the core, and it collapses down until it gets to be a preform. They then take the preform and mount this into a drawing tower. This is multi-stories high. They actually mount the glass tube in this drawing tower. The bottom of the preform is heated until it's a consistency of like taffy or thick honey, if you will. Here's the part they put the preform in here and heat it up. There's the heating of the preform there. And then once they heat that preform, and you start to get it to almost kind of drip off, they control that. They grab a hold of that dripping off part, and they very carefully pull it down through and wheel it onto or roll it onto a drum down here, onto a wheel down here. And the process of pulling that strand off, almost like you take a spoonful of honey out of a container, you get the big gob that comes off, and then right behind it for a while you get a nice, even, steady stream. That's what they're doing. They're going to grab that nice, even, steady stream of that glass being heated, and that becomes the fiber optic. That becomes the fiber for the fiber optic. Pretty awesome. I actually have a How It's Made video that shows you this process. They actually show you this inside vapor deposition process of making a fiber optic. That really kind of makes the whole process a little more clear to you. I would encourage you to take a few minutes and watch that as well. I have a link of that on D2L here too. So I'm going to stop there. When I come back, we'll start talking a little bit more about some of the technical principles of fiber as well. But there's a little bit about how fiber optics is made.